Yo guys, I'm back again to keep recording about how to find the flows through pipes and the net flows through pipes from the previous video. So, as I looked over, there were some mistakes made as usual. So, one of them was you just want to find that the zero, so a Q. And then, yeah, this is the same, and this is going to actually be a plus. So I believe to find out the zero Q equals 1. And actually for here, we use a different delta. So let's say delta H, delta head. And we're going to use that same delta head down here. So actually, let's run it. And yeah, it successfully works. So we're going to need now, so we actually want to test this. We're going to need, so let's say we're going to need define some delta H is 40. L equals 10. G equals 0.1. And we're going to need a Q guess. So initial guess for Q to solve for the flows. Just like we had before, you need a good initial guess for F as well to solve for the Q. So that's going to be implemented in this Q guess. So Q guess. So as we do, we're going to have, it's going to be the same thing that we had before up here. Except now we're going to actually enter the values of velocity. So we're going to mp dot pi times diameter squared, I believe, divided by 4. Multiplied, I believe, so mp square root the negative of delta H, I believe. I don't know if it's delta H or delta head, so I'm just going to say delta H times, so was it times up there, plus, so plus K times 4, instead of the RE, so the Reynolds number and relative wetness, we're going to make a guess, like we said earlier. And this guess is going to be 0.1, which is a fairly good guess for F. And then it's times the same thing, times L divided by D. And this whole thing is divided by 2G. So invalid syntax means more than likely parentheses was wrong somewhere. It doesn't look like it actually. It always is. Always the 2G that catches me. If you do that, K is not defined. Yeah. So K is equal to 1.5 as usual. And there I don't know if this is delta H or delta head. I'm pretty sure it's delta H. But I messed up here. This is divided by. All this encompassed, so I'm going to need another parentheses here. So as I got that, and it's saying invalid encountered square root. So we have a problem. The problem is there's a negative under this delta H, so it can't run the function properly. So we're going to have to make some changes, probably farther up the chain to make sure there isn't going to be a negative. But while we do that, we're going to have to account for the sign switches. So I believe the first thing we're going to have to do is go back up to the head function. I don't know this for sure. We're going to have to account for an absolute value for velocity in case it's negative an absolute velocity. And we're going to account for the signage at the return. So mp.abs, and this helps since I already have the parentheses there. And now this, instead of that, mp dot, what's it called, sign. I don't know what I just did. So mp dot sign q times But is it negative sign or just a regular sign? I believe it's negative. So as we do that, shift enter, it doesn't affect it. And it still says invalid encountered square root. So for the encountered square root, let's just change this to negative 40. Let's see how that runs. Eventually it's going to have to run with both. And now we got to run the function. So I believe it's Newton. So we have that f to 0. I don't know where the second function is. So delta h. ed is not defined. E is not defined. It's not delta, it's q guess. That's what we need. Q. So let's say guess. Hopefully this works since it's somewhere ed actually isn't defined. I might just have to put ed in here. So e d is equal to 1 e to the negative third. And I believe I got this wrong. I believe it's times 2g. Let's see. V is not. Oh, okay, no. You shouldn't have to define this one. Oh, V is not defined because of that. Should be small v. And it gives me 0.118. And that's about to answer what I want. Something around in that range. So now that I got this, I believe I can move this function here up there. So let's do that. And actually let me see if it's 40. It didn't fail to converge. I think I made an error up here. I think there's supposed to be a negative sign. But I still think there's more work to do. So I'll just leave it at that. And I'll leave it at negative 40. And that will be fixed later. There's probably still more absolute value signs to do. So put you up here. That cell's unneeded. Indent all you correctly. Let's get rid of you. And since I can't see, let's move my camera. Put this down here. Let's see if it works. Yep, but we're gonna have to make some changes here. So I'll move you down. I'll actually put the QGuess in this function here as well. But what if like we said, we need to change this so it can make it negative no matter what sign. We also want to put that resulting flow rate in here. So let's say resulting flow rate equal to Control C. That, and actually I should have moved that down up. Since I'm going to move this up, we want to flow. So what's a flow of 1.0? So 1.5, 10, 0.1e to the negative 3. It wants a delta head, negative 40, and a d of 0.1. And it's not shift enter. Once it fully is, put that up there. Let's see. I think I put outside this indentation. This delta should be, this flow should actually be negative. So I'm gonna have to change some things. The first thing is I think we're going to do delta H, delta ABS. We're going to take the absolute value of the delta. So it's equal to, so delta head, so mp.abs of delta H. And we're going to have to implement that here. So go mp.abs delta H. But to account for that, we're going to have some signage change either here or below. So you're also going to be delta dot ABS. I believe you're going to be a negative down there. The question is, where do I put the signage change in this function? So the sign change, I believe, comes at the very bottom. It's np dot sign of the original delta H multiplied by that. So let's give this a shot here. And now it says of course delta ABS isn't defined. And it isn't. I shouldn't have that. This should just be delta ABS. Invalid syntax. It means it's up here somewhere. So, yep. And let's see if I change this to, oh, where did it go? Oh, I'll move my thing up. If I change this to 40, it should give me a positive number. And it does. So it works the way we want it to work. So now we got to start working on the pipes array. So it's pipes equals mp.array. And I'm going to port the values over, so give me a second. So I got the values, so Control V. Let's change this to pipes. And that's the pipes array. So what we're going to need to do is positions. So Z is the positions of mp.array. And the first value, so the flow going inside the whole system is 30. The rest is going to be 0. Let me make a space there. I don't like how that looks. And what else are we going to need? We're going to need the pressures. With pressures, let's say external. It's not an array. This is going to be 2e to the 5th and 0. We're going to need the external nodes. It's going to be 0, 4, equal. We're going to need the internal node, from nodes actually. Right. From nodes to nodes L values and K values. So these are just going to go to pipes. Zero. Go to pipes. 1. Control Z. I want to do this before this video ends. Pipes. 2 and 3 And I'm going to have to continue this in the next video.